Good morning, everyone. Thank you for being here so early in the morning on Friday. So I'm going to talk about a tool we developed at Verily called, like at the beginning, we codename it as Wasabi. We thought it's a cool play with all other tools like fish and sushi, but later we realized that, it's better to go with a definitive name. So we rename it to Fish Linter. So sorry about the confusion. A little bit about myself. I'm a software engineer at Verily, based in Canada. And before that, I was working at Google for about 10 years. Okay, let's start with the problem statement. Why did we even decide to build a fish linter? So at Verily, we have an internal IG, which is shared by all teams, and it gets contribution from almost all engineers. We have, on average, daily about 3 PRs that are merged to our fish code, and then based on that, we build the IG. So because of that, because like a lot of engineers contribute to that IG, we get a lot of inconsistencies, and then it will make the work of the reviewers very hard, because all the time we need to say, oh, please rename this field, please do this. So we realized that if we build a linter, we could automate a lot of those rules and make the life of both authors and reviewers much easier. So what we did, we basically built a command line tool that can analyze fish files, and then basically follow a couple of rules, and then if any of those rules are violated, we will show it to the author. And this tool is being automatically run using GitHub Actions. So every fish PR that is merged to our repo, we will run the linter automatically, and then we add the comments to the PR, and that way the author can address all those issues. We started with a set of predefined lint rules for ourselves. So for example, we have a couple of rules related to naming convention. We make sure the names of profiles, extensions, value set, code system, they follow standard that we follow for our code. There are some other common sense checks, such as, for example, hard-coded URLs. If we have hard-coded URL in any fish file, the linter will detect that, and then we will ask the author instead to use an alias and use the alias inside the fish code. And also, for some cases, such as search parameters, because this happened a lot, that somebody added a new search parameter using fish, we pushed it all the way to the production, and then we realized that there was an issue in the search parameter. So we also use the fish linter to enforce some process. So for example, if somebody is adding a new search parameter, we ask them to perform an end-to-end test, basically create the search parameter JSON file, import it into a FHIR store, conduct a search, and make sure that it does what they want to do. So this is another aspect that the linter can easily enforce it. So in addition to that, also, the linter can auto-fix files. So basically, when you run the linter, you could run it in 2 modes. Either it will just tell you the issues, or if you add --fix, it will also fix those issues if it's possible to do. In the demo, I'll show this capability. And the other thing that we were very aware of it was that we wanted to build this fish linter that can be easily adopted by the community. So it's super easy to add a new rule and then start enforcing your rule. Again, I'll have a demo and I show this, but we were very conscious about this to make it reusable by the rest of the community. So I'm going to just very quickly talk about a little bit of the technical, how we did it. So we used the fish grammar defined using ANTLR that the fish team used. Again, kudos to them that they use this ANTLR, because I remember a few days ago somebody else talked about Babelfish tool, which again they reuse the grammar. So this was a great choice that they did. They enable other teams to basically play with the fish grammar. We implemented in Go. Almost all our code base is in Go, so that was not a choice that we had. And also we use the visitor pattern, which makes it very easy to write a parser using Go. I should say that the parser is partially implemented. We didn't implement the entire parser. I'll show it again later on the code base. But again, it's super easy to add new features to the parser and make it complete. And then again, we followed proper software engineering guidelines, like all our components, all the parser components, they have a unit test. Rules, all of them, they have a unit test. Again, I'll try to briefly talk about this while we look at the code together. Okay, so against all the common sense, I'm gonna show you a couple of demos. Hopefully everything will go fine. So first we are gonna take a look at the repo. I'll show you the parser, the unit tests, some of the existing rules. Then we will try the linter in 2 modes to detect, first to detect the issues, after that to fix the issues. And then at the end, I have a short demo of how a new lint rule can be added in literally less than a minute. Okay, so let's start looking at the code base. So luckily this one we had time, one of my colleagues helped with the open sourcing it, so it's available and you can take a look at the code. So here it's the fish, and then if I go to internal parser, so here is the parser, and then let me. So for example, here for the code system, as you can see, we just received the object, and then after that, we could extract the ID, the title, description, and then after that, we iterate over all the concepts, even if it's it has a hierarchy ancestor, we extract all of that, and then we add the concepts to the code system object and we return it. So similarly, if I look at the visit profile, almost the same thing. So here we receive the object, and then we start extracting the parent, ID, title, description, and then if there are rules, we extracted, added the profile rules, and we return it. So the parser, again, for people who are familiar with Go language, it's super easy and straightforward to extend and complete. And then for the tests, so as you can see, we have this fish parser test for the unit test, and then we have a test code system all in fish. So this will be given to the unit test as the input, and then this is what we'll expect to receive as the output of the unit test. So for every feature of the fish parser that we implemented, we also added a unit test along with it. So if I go back here, so we have, so again, we try to, in our main README file, you could see that in the code system, these are the fields that we extract, and then these are the couple of rules that we enforce to it. For extension, again, these are the fields that we extract from the extension, and these are rules that we enforce to it. And then you could basically our goal is that as we make the parser more complete, we will add more features, and more of these fields will be ticked in future. So this was the parser and the unit tests. Now let me show you a couple of rules that we have. So for example, code system name matches ID. So again, for people who are familiar in Go, it's very straightforward. We this is an interface. We just each rule has a name, each rule has a message, and then here is basically the main validate happens. Here we receive the code system, we look at the name, we look at the ID, excuse me, and then if they don't match, we return the error. So it's super easy and straightforward to add new rules. And then I don't know, if, for example, if you want to add some prefix limitation to your code system or your resources, it should be super easy to add. Okay, and now let me show you the linter in 2 modes. Okay, so here what I did basically, from Fish School, I downloaded a profile, and then I downloaded the code system, and then together we can take a look at this. So at the beginning, so basically this is how we run it. We have the fish lint dash path, and then you could point it to a directory full of fish files, and then it will start enforcing rules all on those fish files. So for now, I'm gonna do it for this profile. As you can see, there is nothing detected, and then now slowly we could modify this, and we'll see how the messages will be shown. So for example, one of the rules that we enforce is that we expect that the profile in Pascal case would be exactly as the ID in the kebab case, and then the title also they are all matching. So if I modify, let's say, the ID to like add a suffix here, you will see that if I rerun the, I need to save, and then if I rerun the linter, you'll see that now it will give me 2 errors. It says that the ID does not match the profile name, and also the title does not match. So this is the first mode that I said, like usually this is what we use on GitHub. We run it, and then these messages will be added to the file. But as I said, you could run it in the with this -- fix input. And now what will happen, it's a bit hard to see, but you'll see that now the linter is able to remove these 2 fields to make like title, ID, and profile are all matching. So if I run it, -- fix, let's see one more time. Okay, so as you can see now, like that suffix of name has been removed. The other feature that we have, so for example, in our profiles, there are a couple of fields that we make them required. So status and abstract, we wanted the authors to explicitly set what's the value for status, what's the value for abstract. So if I remove one of these 2 fields again, and then rerun the linter, you will see that it is complaining that the status is missing, and then status must have a value. So this is like, again, this is one of those custom things that we needed for ourselves, and linter can easily enforce it. Okay, so let's now switch to the code system. So for the code system, the same story. Like again, we want the linter to make sure that the code system ID and the titles, they are all matching. So again, here, if I run the linter for code system, you could see that here it's complaining. It says that the title does not match the ID. And so if I rerun this using the -- fix, let me see why. Okay, let me try one more time. Maybe that's why, yes. Okay, let me save this, overwrite one more time. Okay, so yeah, now you could see that the title has been modified. Like the other type of rules that we enforce is that we require that all concepts that are adding in a code system to have exactly a display and a definition. So for example, if I remove this, you will see that the linter will complain that the display or okay, I don't know. Okay, so another rule that we can enforce, maybe like we remove that as an internal, is that the code system must not be empty. Let me see this one. Save again, thank you. Okay, again, like maybe, because some of these rules, we remove them as internal, maybe that's why it doesn't show. But in any case, like all those rules can be easily enforced. And then finally, I want to show how a new rules can be added. So this was recorded by our, like majority of this work was done by our summer intern. So this was a recording from her work. I will show you. So basically at the beginning, what is happening here, we create a new profile, penguin profile, like they just name it penguin profile. And then now in order to add a new rule, we have this like rule template.go. You could just copy the rule template.go and then create a new rule. So in this case, they will add a penguin rule. And then after that, inside this Go file, like they just again rename the template. It has a name, and then here this is a message that when the rule fails, like this is what will be returned. And then here you can see that this file context that we receive, we will convert it into a profile. Like basically, if it's a profile now, we try to extract the name from it. So as you can see, parsefish profile, and then here the profile will check the name of the profile, and if the name of the profile has a specific prefix, which in this case, like the string penguin, then we'll return the message. So here is how the new rule is being added. And then if basically if this condition happens, we will return the error message. So after you create your rule, now all you need to do is that you add the new rule to the list of existing rules. And then as soon as you do that, when you rerun the linter now, you will see that you will linter start enforcing this rule, and then it will show the message. So as you can see, in literally less than a minute, you could add a new rule and the linter will be able to start enforcing it. Okay. So that's it for the demos. So at the end, I would like to thank my colleagues. Again, at Verily, we are a big team of engineers. We are building a very comprehensive code base of Go language for processing and manipulating FHIR objects. It's I'm glad that we have a chance to open source part of our work via this presentation at FHIR DevDays. I would like to thank Crystal. As I said, she was our amazing summer intern, and then most of this work was done by her. Bikram led the project, did the overall design and architecture, and Matthew, another TL at Verily, he helped a lot with the code quality and later open sourcing the project. And again, at the end, I would like to thank FHIR community. A lot of time we didn't know something, we asked question on Zulip, we asked question on GitHub, and then everyone is very helpful and welcoming. So that's glad to know, and I'm glad to be part of this community. And finally, here there are the contact information for myself. As I said, the code is already available on GitHub, so please feel free to start using it. And then if there is any feature request, we would like to help and improve the tool. And finally, the presentation also is available here. Thanks, everyone.
Thank you. Any questions?
Thanks, Saman. This is a really great effort. I have two questions for you. How do you think it would be to add a rule for consistency in something like canonical URLs? So say you wanted your organization to create canonical URLs the same way. Would that be something that could be added in the rules that you showed? And then do you have any sort of broad recommendations for any organizations that want to create an internal IG for their own company or teams to use, and talk about your experience at Verily with that a little bit?
Definitely. So for the canonical URL, fish config has this feature, there is I can't exactly remember the field name, but there's a field name inside the fish config that you could set that, and then that will set your canonical URL for all your resources. So basically you do that, and then when the sushi compiles your fish file into JSON, it will add that canonical URL to all your resources. So you don't even need this tool to do that. That already exists. So that's the first. And then the second question, to be honest, we found Fish very helpful for developing IG, especially for a large organization with a lot of people contributing to it. So I would highly recommend using Fish to build your IG. And then, there are a lot of things that we learn along the way. For example, we learned a little bit late that it's better that all extension to have a prefix dedicated to Verily. Otherwise, there might, when they are exported via SQL to FHIR, there might be name collision. So there are lessons like that we learn a bit too late. Maybe the other thing is that knowing that at some point you will be updating from R4 to R5 or R6. So the talks that Gino had yesterday, I found it really helpful. So that way, if you use those standard extensions, so in future, migrating from R4 to R5 and R6 will be super helpful. So again, we did not do some of those at the very beginning. At some point we realized, and fixing was a bit hard, but I would say that following those community recommendations are very helpful. I hope I answered your question, but again, we could catch up later if there is more questions to answer.
Thank you. Any other questions? No? I think we're at time, actually. I don't have the clock with me now. Yeah, we're at time. So thank you, everyone. Thank you, Saman, for your presentation and talking about the fish linter. Yeah, that's it.
Thanks, everyone.